Hi, welcome back. Today we're going to be talking about providers. You might know that the AzureRM provider contains lots of quality of life improvements that go over and above the sort of CRUD operations that the normal API calls would provide. But what do we do when we're using AzAPI? Well, keep watching to find out. So the use case for today's video is the subscription vending machine module. It uses AzAPI because it allows us to create a subscription and deploy resources into it in a single apply. But in using AzAPI, we actually lose some of the cool stuff that AzureRM provides. One of those features has been raised as a GitHub issue on the repo and is to do with resynchronizing a virtual network peering when the address space changes. So let's have a look into this in more detail. So let's start by looking at how you actually sync the remote address space of a peering anyway. Now, obviously in the portal, you can click the button, but what's it actually doing behind the scenes? Enter the REST API specs for virtual network peerings. We're looking at the create or update operation here, so an HTTP put. If we look down here, we've got a section on URI parameters. Most of these are self-explanatory and are part of the path, but there are a couple of query parameters. Now, obviously the API version, which is mandatory, but then you have this sync remote address space option, and that is a query parameter. If we go down here, it's just set to true if you want it to be true. So, okay, so let's go back up and look at the examples now. They've got one for sync peering, so we can see what that looks like. So this is a standard put to a virtual network peering resource. You can see it's a virtual network called vnet1, a virtual network peering called peer, and then we have the query parameter sync remote address space equals true. Cool, so that's how we do that. Now let's look at the AzureRM provider, because apparently that supports this feature, but I didn't know how it did it until I went and had a look. So this is the code from the AzureRM provider. You can see it's the virtual network peering resource code, and we're looking at function resource virtual network peering create. So this is the function that's run whenever you create a virtual network peering. And this line here, line 143, is when it's calling the client to create or update the peering. And you'll notice this last parameter, network.sync remote address space true. Essentially, all that does is pass a custom type, which is based on a Boolean. So it just passes the value true, essentially, to that client function. And it does it on the creation of a peering. And actually, it also does it on the update of a peering. So this is the update function, which is slightly different. It's a different function, but it's the same client call, and it's got that network sync remote address space true parameter on there. So actually, in AzureRM, you'll only synchronize the remote address space when you either create the peering or update the peering. Interesting. Does that mean that it won't do it if the address space of the reference virtual networks changes? Because I'm not sure the peering object would know, would it? I haven't tested this out, but it'd be an interesting one to try. What I want to do, though, is for AzAPI, I want to use Terraform to actually query the state of the address spaces of both virtual networks on either side of the peering and update the peering and resynchronize the peering if the address spaces change. Let's have a look and see how we can do that. So here we are in VS Code. I've created a little demo for this, and I've broken it up into two Terraform states. So the first state is for the hub network, and the second state is for the spoke network and the peerings. So if we look at the hub network, we can see that we create a resource group and we create a hub network, so a virtual network with an address space. All very standard. I then output the resource ID for use in the spoke module. So this is the root module here. We can see that in locals.tf, I have got the hub network resource ID. So that's the hub network that I've just created, vnet hub. And I've also got the bodies for the virtual network peerings. I'll explain why I've put them in locals in a minute, but essentially I've just done the JSON encode to make it into a string and stored it in that local there. Let's have a look. I've got separate files here to make it slightly easier to read, but we've got the vnet peering from the hub. So we've got the vnet peering from hub, and the parent ID is the virtual hub network resource ID, and the body is that local, which essentially points it to the remote virtual network that we're creating here. And then we've got the peering from the hub and to the hub. Both of them are in there, essentially exactly the same. we've got the to hub body there and the from hub body there. We create the virtual network, as you'd expect, in the resource group. And these are fully applied. So T apply would mean that it says no changes. And if I get to hub network and I go T apply, then there are also no changes there. This is reflected in the portal. So if we look here, we've got our two resource groups, one for a hub and one for a spoke. If we look at the spoke network, we've got the vnet spoke. And we can have a look at peerings. And you can see the peering is connected. So that means both halves of the peering are created and in sync with each other. Okay, so let's start adding to this code now and seeing how we can make this a little bit more clever to start resynchronizing these peerings when the address space changes. The pattern we're going to be using to do this is the Terraform data managed resource type together with replace triggered by. And what that allows us to do is store data in a Terraform managed resource, which is built in. You don't need a provider for it. And using replace triggered by, we can essentially create a chain reaction of events that will trigger Terraform to do something when another property of a resource changes. So they've got an example here. So you've got a Terraform data resource here, which has got a var.revision and an example database here with a replace triggers by the Terraform data.replacement, which is this thing. So essentially, when you change this number here, this resource will be recreated. That's not quite what we want, but AzAPI has got some resources called AzAPI action resources, which enable us to do almost like curl or AzRest kind of commands, but built into Terraform, so we can run it in a managed and structured way. Let's have a look at the code to see how we do that. So first of all, we're going to see this in action. I've got the same code as I did before, but I've added a few extra bits to make this vnet resync work. So let's just prove everything's fine. So we got Terraform plan here, and we see no changes. If we go to the hub network, we've got Terraform plan, and there are no changes there as well. Now, what I'm going to do now is put this window here. What we can see is that the vnet peering is in a synchronized state. So it's from the hub. Perfect. So the from the hub one, if we change the IP address of the spoke, that would normally go, I need to resynchronize. So let's go and do that and see what happens. First thing, we need to change the address range of the spoke, 10.0.10/24. Okay, done that now. If we clear, I'm just going to use a little utility that I wrote to display the plan output in a kind of summary way. Oh, why didn't that work? Oh, because I'm in the hub network. There you go, Matthew. So we're going to run a little utility. That's going to says it's going to do some stuff, but I'm going to run this utility called tfPlanDoc. I'm going to show you exactly what's going on in a nice summary way. So most of the resources there's no op. The vnet spoke is going to be updated because we're updating the address space. Yeah, that's expected. Then we've got this time sleep resource in here, which I've added because you need a little gap between updating the address space and then resynchronizing it, because sometimes it doesn't realize it needs resynchronizing. Then you've got this AzAPI resource action vnet peering from hub sync. So this is the new resource I've added to actually synchronize the peering. And you'll notice that it only does it when the virtual network changes, when the spoke vnet changes. So let's go and apply that now and see what happens. So you can see that it's modifying the virtual network. What I'm also going to do is speed this up, because obviously there's a 20-second sleep in there. Okie dokie. So that's done it. That's changed one. That's the virtual network. And it's done some other stuff as well. If we just go back to the portal quickly, we can see if we give this a refresh, that peering is still in sync, which is fantastic. If we look at the spoke network, we can see the address space has got both address spaces in it now. So that's cool. We've added that, and we've then resynchronized the peering all in one operation. What's cool is that this is idempotent as well. So if I go to Terraform plan, now it'll say, cool, I don't need to do anything. or it should do. There we go. Cool, no changes. It's in sync. So there we can see we've got an idempotent way of resynchronizing a VNet peering when the virtual address space of the virtual network changes. So let's have a look at how this works. If I look at the peering from the hub, we've got that trusty time sleep, and that is replaced by the VNet spoke being updated. So any change to the VNet spoke means that this time sleep will be recreated. Now, I wasn't able to be specific and only change it on the address space, but hey, this is pretty good still. Then what we do, this AzAPI resource action sync is triggered by the time sleep being recreated. So it will then recreate this resource action. The nice thing is, because this is a resource action and not a resource, the delete operation on this is a no op. It doesn't do anything. So that means it's not going to delete the VNet peering. It's just going to update it whenever we do a create, whenever we do a put. So essentially, when this virtual network changes, we're going to wait 20 seconds, and then we are going to resynchronize the peering. Now, the way we do that is by adding on this parameter onto the resource ID and telling it to do a put over the top. Now, this is why we had the body of the request in a local, so we can be absolutely sure we're not going to make any changes to it when we do this. So that's how that works. By chaining these things together, so any update to the virtual network, sleep for 20 seconds, then run this, that means that we can resync the peering whenever the address space changes. Well, that one certainly took some time. You may have noticed the costume change halfway through. That's because essentially I've been refining this solution over the last couple of days and actually made it quite a lot simpler than it was. I had around 4 or 5 resources all chained together at one point, and then I realized that that wasn't necessary. I hope you find it interesting. As ever, the link for the repo will be in the video description. If you have found this useful and enjoyed it, please give us a like and a subscribe. It would be much appreciated. And as a little bonus feature, I'm going to show you how the opposite way around works, in that how we detect changes in the hub network and resynchronize the peering on the local side. So yeah, if you want to see that, stick around. If you just want to check out the code in the repo, it's all up there. Please do so, and see you next time. As a little bonus feature, I'm going to show you what happens when the hub network changes as well. If you want to have a look at this, we're going to add another address space to the hub network. 168. Oh no, I can't do that. Let's just do 172.16.0.0/16. Okay. We should be able to see now that the address space is being added. So if we apply that, we can now see that the hub network address space is going to be updated. Okay, so that's fine. And what you'll see now is in the portal, eventually you should see the peerings, and it's local sync required. Okay, so because the hub network is in a different state file, we can't automatically resynchronize the peering because we don't necessarily, because the peering's been created in another state, so we don't know which ones exist. So in the model that we use for landing zone vending machine, we do this all from the state file that contains the vended landing zone plus the virtual networks and peerings. So if I go like that and go Terraform plan, what we should see is that, there we go. So stuff has changed, and it's going to replace the sync resource again, because we've got data sources and things. Okay, so if I go to Terraform apply, I'm going to say yes. And it's now recreating the sync resource, which is going to re-put that peering with the sync remote address space parameter on top of it. And it says it's done it. So if we go into here and click refresh, it's fixed. So there you go. Quick look at the code for that one. We do this slightly differently. So we've got the peering that comes to the hub from the spoke network. We've then got a data resource, which pulls out the data of the remote virtual network, and we export the address prefixes value. Because you can't use replace triggered by on a data source, you have to then put that into a Terraform data resource, which I've done here. I've just chucked in the data in there and JSON decoded it. Then I've got exactly the same action as we did before. So AzAPI resource action, sync the hub with the sync remote address spaces, and make that dependent on the Terraform data resource, which stores the hub address space. And that's how you do it.